Hi, this is Trev and welcome to my blog. Welcome to part 1 in the mini-series of MIG welding. So I've been asked loads and loads of questions over the years, and what I've done is I've compiled the repeated questions and I was going to put them all into one video. And I suddenly realised this video is going to be absolutely massive, and we know how upset people get when things go past the half-hour mark. So what I thought I'd do is divide it into 3, so you've got 3 videos to look forward to watching. I've practically shot it all, so there'll be one after another. There won't be any great big breaks in between. And so part 1, this part is going to be all about power settings and wire feed settings. Part 2 is going to be about hands-on welding more. It's going to be more about doing plug welds and butt joints. Also going to discuss the difference between MIG and TIG, the advantages, disadvantages. In the third part, I'm going to talk about gas settings, and I'm also going to talk about the confusion between the whole volts and amps thing that people have got themselves got it all wrapped around their head. I'll try and demystify, I'll try my best. Obviously, I'm not a welding expert, and I just use welding in my job. I'm not like a production line welder or anything like that. The things that you're going to see in this video are going to be things that I've I've come up with myself. I'm going to use a lot of analogies, a lot of metaphors to try and get my point across. So there's going to be a few holes in what I say, but hopefully you'll have a better understanding of what's going on, rather than listening to a true expert that just baffles the hell out of you. So let's get back to part 1. As said, this video's been made off the back of all the questions I've been asked over the last couple of years. So I'm going to assume that the viewer knows absolutely nothing about welding, and we're going to start right at the beginning, right at the basics. This welder, it's also a stick welder or arc welder. It's also got a spool gun attachment so that you can weld aluminium. I haven't got that, so I can't show you that. So let's just discount this side of the welder. All we're really focusing on is these 2 dials here. So we've got a voltage or power control. So if you've already got a MIG welder, and more than likely you've probably got a stepped switch on your welder, because that's more common. This is an inverter welder, so this is variable. So you'll probably have a variable wire speed and a stepped switch if you haven't got an inverter welder. Now it's no different to this at all. It works in the same way. The welder works, the technology behind it works differently, but the actual welder will be similar characteristics. So I can talk you through exactly like for like. We won't get lost. Put basically, to successfully MIG weld, all we need to think about is this voltage stroke power control. Now, if you're welding something thin, you need it quite low. The thicker the material, you keep winding the power up, and it is as simple as that. Something that's really thick, you're going to use the higher power. Something that's really thin, like car body stuff, which is more what I'm sort of used to welding, is going to be right down here somewhere. And anything else in between, like I say, as it gets thicker, you just increase the power. And that is really as simple as it is. That's all as simple as it needs to be. Now, all we need to do then is to match our wire speed to our power setting. So it's no more complicated than that. So you first dial in the voltage you want. So you'll dial that in, you'll think to yourself, well, this is quite thick stuff. It's much thicker than what I've been welding, so I'm just going to turn the power up. So you will do that to start with. So you power up to where you think, and then you adjust your wire speed to match the voltage. And I'll show you how to do this. So you keep adjusting the wire speed, starting from a lower position. I would first, if you're not used to welding, start from a low position first and work your way up until the welder is welding at its optimum. Now, if you haven't got the penetration required, so you can tell that you're not getting enough heat there, because heat equals penetration, then what you need to do is put more power on. It's as simple as that. Put more power on, and then adjust your wire speed to suit again, and then assess where you are. You know, if you're blowing holes in things, then you've got too much power on, so you need to down the power, down the wire speed, and then set up the wire speed again. And it really is as simple as that. I got a bit of a test rig mocked up here, got a piece of steel in, it's only thin stuff, so I'm going to weld this at quite a lower power setting because we don't want to be blowing holes in it straight away. Now what this part of the video is it's all about matching the wire speed with the power setting. So basically just setting the wire speed up. We're not going to be looking at weld quality, we're not going to be looking at the penetration necessarily, but what this is really all about, it's all about showing you how I can start with no wire speed on, keep turning it up until we get to the optimum wire speed, and then keep turning it up too high so that we show you what you don't want as well as what you do want. So here's our finished weld. I could have done with the power just turned up a little bit more than I had, but for the purposes of this demonstration it was pretty much perfect really. So this is the start point of the weld. So when I was welding it, the welder was making this kind of noise. Now I refer to that noise as a stalling noise. So I would say wire speed too slow and the weld stalling. You can hear that it's sort of intermittently arcing out and not really doing a great deal. And then as I increase the wire speed, you can hear it making this kind of noise. And you can hear it continuing on as I increase the wire speed more and more and more, until in the end so much wire is coming out that the welder starts to stutter, what I would call stuttering. And this is where the wire is coming out so fast there aren't enough amps there to melt the wire. So what actually happens is the wire's coming out of the torch and hitting the workpiece, and if you've ever experienced this, you'll actually feel the torch trembling in your hand, and that trembling is the wire hitting the workpiece, because of course when you're MIG welding, the initial contact to strike the arc is the only time the welding wire should actually hit the workpiece. Once you've actually got an arc going, then the wire is melting before it actually hits the workpiece, and that's why you don't feel anything when you've got it set up correctly. So this is what it's doing here, it's stuttering out towards the end. Now I'll talk a little bit about weld penetration now. So as you can see, this area, I mean, like I say, it looks a little bit thin and weedy, the weld, to be quite honest, but this kind of area from around about here to about here, it looks pretty good. And if I flip it over, you can see that it's a bit it's a little bit smoother, it's a little bit more desirable from like an appearance look as well. You can see that it's doing something. So if I flip it over and keep the camera in roughly the same place, we can see weld penetration that's gone all the way through the steel, popped out the other side. This is the kind of thing we need to be looking for when we're talking about the strength, because if the weld isn't penetrating into the steel, then you're not getting a strong weld, and that's what it's all about really. It's all about making something look, obviously make it look nice, but also when it looks nice you know that it's kind of penetrated in. So this is what setting up the wire speed is all about. You keep speeding the wire speed up until you get to a point about there, and what you can do is what I'm going to show you next. It's just basically running beads across pieces of metal and then observing what's going on behind to see what sort of penetration you're getting. So that's what I'll show you next. I've got some small sheet steel samples here. Now these are 1.2mm thickness, and this was 1.2mm thickness. Now the reason I've used 1.2 is because it resists blowing through far more than standard 0.9mm, which I would use for outer skin panels on cars, and that's why I'm using this. What I didn't want to do is I didn't want to get halfway down our test piece and then blow a great big hole in it, which it probably would have done if I was using 0.9. So that's why I'm using this stuff. So what I'm going to do is I may only use 3 or 4 of these, I don't know yet, but what I'm going to do is run a bead down the centre of each one and try and show you the difference in penetration to wire speed. So I'm going to set the voltage or the power at a certain point, and I'm not going to touch that, and what I'm going to do again is just increase the wire speed each time, and then we can, you know, we can break it down and we can see the difference. I'm going to put a lot more power on this time, and I'm going to do that because there wasn't an appropriate amount of power on the last test subject, but on this one I want to show you the characteristics of what the sort of weld looks like when you've got a bit more power on. Hopefully we'll see the weld absorbed into the steel more than just sat on the surface. So I got 3 good samples that are fairly representative of what I was trying to show. I couldn't actually get the welder to weld badly enough to show you the slow one, to pick up the correct characteristics of normally welding too slow, which is a lot of heavy undercut. I've got a little bit of undercut going around here, but overall it's come out better than I sort of hoped it would really. Sounds a bit bizarre to say that, but there you go. So we're looking at the weld. It's a messy looking weld, and it's too flat, too wide, and it's got undercut, and that is characteristics of welding with too little wire speed. So we move to the best one next. Perfectly satisfactory weld, not too wide, and it's not stood up too high either. Just a really nice, well proportioned weld. I'd be very happy myself if I was doing a project and all my welds ended up like that, chuffed to bits. So next, too fast. So what's happening here is, of course, the wire's coming out so fast there isn't enough of amps available to melt the wire, so the wire's not arcing properly, and a lot of it's driving into the workpiece and then just sort of snapping off on impact. You can see that the weld's very tall, mostly sat on the surface. So let's flip them over and let's see what they look like the other side. This is the one that was too slow. We got a little bit of penetration going on here, but nothing too much to talk about. And this is the best one, of course. Now the best one, you'd almost be forgiven that I haven't turned it up. So let's look at the other side again. It's almost like a nice tubular weld on a flat plane. Look, it's like a tube sunk into a flat plane. It looks the same both sides. Couldn't ask for any more really. And the one that was too fast, again, very little penetration. If I compare the one that was too slow, then there's not really much difference between the two, is there? So no penetration when it's set too fast or slow. Excellent penetration when you get the wire speed set to just about right. This is the Goldilocks zone here. Another repeat question I keep getting in the form of emails normally, people sending me pictures of the panel work that they've welded together and they've ground the weld off, and you can see a line underneath where the weld just hasn't penetrated. I honestly believe that this comes from being a little bit worried about the welder. They've tried to weld some out and blown a great big hole, and what they found is they've turned up the wire speed, which stops it from blowing into a hole, but now they haven't got the penetration. So what I'm going to do is try and weld this badly enough to kind of demonstrate what happens when you weld with a wire speed set far too high. It's an observation, I think on my last video I mentioned it, it's an observation. A lot of guys that I've worked with that have come to me and said, oh, the welder's not welding very well. And I kind of lean across and just nudge the wire speed down a bit, and often things improve no end. It's not always as obvious as it seems, but like I say, it's just an observation of mine. So I'm going to weld this with low power, low voltage, and wire speed that's too high, and I'll kind of show you the scenario that a lot of people run into. This is fairly typical of what I would have seen. Somebody have sent me a picture of something that they've welded up. It looked kind of like this, and it could actually be welded, in all honesty, it could be welded up okay, but from this outside perspective you can't really see what's going on under the surface. So I've welded this very low power, very high wire speed. We'll grind this off and then I'll show you what's going on under the surface. With the weld ground off flush, it looks, to all intents and purposes, not too bad. You can't really see a line there or anything, and it's quite flush. Watch what happens when I start putting some movement into the panel. I'm going to do exactly as I showed you earlier. I'm just going to knock the wire speed all the way down, and then I'm going to match the wire speed with the voltage to get the optimum penetration and weld that panel across. I'm going to use a kind of pulsing type weld that a lot of people use. I have done lots of videos with a gap, but I'm not going to do that this time, just for the purposes of this video, just to show you the penetration. I use exactly the same two pieces of metal again. So the weld now looks completely different to what it did before, when I welded it before, and we're welding exactly the same power setting, just a lot lower wire speed. If I flip it over, you see we got excellent penetration on the back. Now of course, I wouldn't weld a joint like this with a MIG welder on a car, because I'm going to absolutely distort the hell out the panel. I have done videos in the past where I've shown you can do a cheats way by putting a gap across and then welding into the gap to get excellent penetration through the other side, but this isn't what this video is all about. You could get away with this on a very short joint and probably get no heat distortion, but anything much wider than this, you're going to be running into all sorts of trouble. If one of the frustrations you're having with welding very, very thin steel or car body work with your MIG welder is that, let's just say for argument's sake, you've got the transformer type welder with a 7 or a 6 position chicken head power switch on the welder, so power or voltage, same thing, and let's just say for argument's sake, let's just say that it welds okay on power number 2. So you set it to number 2, but you're just not getting the penetration you could just do with a little bit more power, you could just do with a little bit more heat, a little bit more penetration. So you turn your switch up to number 3 and then just blow a great big hole in the panel. This is an extremely common problem that people have. So I've done a graph here to try and explain what's going on, and I've worked out a solution to this problem, and it's fairly straightforward. So we've got, on the graph, we've got wire speed here. So this is wire speed from 1 to 10. So obviously the dial is all the way down at 0, and then you just turn it up and it comes all the way up to number 10. On this side here, we've got weld penetration. So this is our weld penetration this side. Our weld penetration, we've got good. So this red line here is where the weld penetration is acceptable, and it goes all the way along, and anything above this line or on this line is perfectly okay. That would be deemed as a great weld. You know, we're getting good penetration, and we're producing a nice strong weld there. Anything below the line isn't penetrating enough. So let's just say, for argument's sake, we're on power setting number 2. So this would be power setting number 2. If we were on power setting number 3, this line here, the gap between there and there would be very slightly longer, and the whole thing would be moved slightly to the right. But basically, it would look like this. It wouldn't look much different to this one. Now, let's say you're on power setting number 2, and wherever you set your wire speed, you're just not getting enough penetration. You can't really work out what to do next. So you think, I know, I'll put it on number 3. So you clock it onto number 3, and instantly you're blowing holes in everything. So you're sort of trapped in this situation where you've got one setting that isn't enough and another setting that's too much. Well, the good news is there's a solution to this. So if we follow the graph, so we go from no penetration, of course, we follow the graph all the way up. Now, as we're following the graph up, of course, what we're doing is we're turning the wire speed up. So as we turn the wire speed up, the graph's following along. So we'll get to a position where we'll turn the wire speed up, so we're getting good penetration. As I showed you in the welding test earlier, you know, kept turning the dial up, and then we suddenly start getting good penetration, and it gets better and better and better, and then it starts dropping off. So it slopes back down. Anywhere in this place here is absolutely fine. Like I said, anything above this line is perfectly acceptable. So what it'll do is you keep increasing it, you'll find that the penetration will drop off, and on a low power setting, this gap is shorter than it is on a higher power setting. I'll show you another graph in a minute of a higher power setting, but just stick with this for now. So what you can do is, looking at the graph, if you change your welder from power setting number 2 to number 3, so as I said, you turn it up to number 3, you're instantly blowing holes. What you then need to do is turn the wire speed up. So we follow this graph because it's going to be a very similar graph on power setting number 3 as it is number 2. So what we do is say there, let's just say for argument's sake you were there, so you were at the maximum part of the graph that's giving you the most amount of penetration, and that's where you are when you turn it up to number 3, or right there on the peak, and you're blowing holes. If you turn the wire speed up, so you keep turning it up, you'll see that this line starts dropping down. So the higher you turn it, the less penetration you will get until you come into the realms of it being unacceptable. So if you're on power number 3 and you're blowing holes, you know that if you turn the wire speed up, you're going to follow this graph till the penetration drops off, and you will get to a position somewhere between there and there where you've got a perfect weld going on, perfect penetration, and you've stepped it up a power setting, and you've got then the perfect situation where you're putting in more wire speed to get less penetration. Now, the confusing thing about this is a lot of forums and a lot of manufacturers' specs say, as a general rule, because they make a lot of blanket statements, they will say something like, the more wire speed, so the more you turn up the wire speed, the more penetration you get. And that's not really true when we're talking about welding at much lower power settings. It may be true for much larger units, for something that's producing lots and lots of power, but for just small MIG welders, then I would have said that this graph I've made, I mean, this is something I've created. Hopefully that's a good tip for you, and hopefully that'll help the people out that have contacted me that are having these problems. Now, you might just think to yourself, as I was saying that, well, the graph drops off as well. The line drops off this side, so we're getting less penetration that way. So you may be thinking to yourself, well, I could turn the wire speed down and get a similar result. But if we remember the 3-plate test I did where we didn't have enough wire speed on, you'll note that the weld sinks into the steel. You get poor penetration, you also get a heck of a lot of undercut. So you're far better off turning it higher than you are lower, because as you go higher, you're actually increasing the chances of getting a better weld, of getting better penetration and a stronger weld. If you go down this slope, then you're going to be heading into the realms of still blowing holes and also having a lot of undercut to the welds. So this is another chart I've done just to try and show the difference of what's going on. So say we were at power setting number 6, we were welding something much thicker, so we're nearly running the welder flat out. Then the graph is going to look more like this, where we've got no penetration right at the start, we've got the wire speed turned right down, and we're just not getting any penetration. And as we raise the wire speed, we get acceptable penetration here, and then we've got a really long arc all that way. Just keep sort of rising and rising and rising. It'll either rise when you're on a highest power setting, it'll either rise and just keep going up, or it may just start to tail off slightly at the end. Like I said, it depends what welder you've got, what thickness wire. In video number 3, I'm going to try and help people out that are confused with the whole volts and amps situation, because there are a lot of very confusing videos and a lot of very confusing kind of online forum type things where people endlessly get lost and confused. And in number 3, I'm going to attempt to give you a few analogies to try and get your head around that. But I mean, all we really need to know is, like I said right at the start of the video, you set your power first. So set your power first to the thickness that you want to weld, and then set your wire speed afterwards to match. And these two graphs have hopefully given you an insight into what's actually going on. Having an inverter MIG welder for car bodywork is certainly an advantage over having a transformer type, because you've got a variable voltage control. You haven't got any stepped switch, so that it means that if you've got slightly too much voltage on, slightly too much power on, you can actually just nudge it down slightly rather than having to play with a wire speed to compensate for the step between the power settings. Well, thanks very much for watching. I hope you enjoyed it. I hope you got something out of it. Don't worry if what you wanted to know about wasn't answered in this video, because there's another 2 parts to come. So in part 2, I'm going to show you some plug welding, some butt welding, welding dissimilar thicknesses together. So 2 different thicknesses being welded together. Don't do a lot of that, but I keep getting asked about it a lot, so I'll do my best to answer it, if you know what I'm saying. I'm also going to show you how to clean welds up nicely. I'm also going to discuss the differences between TIG welding and MIG welding on car body work, and the advantages and disadvantages, hopefully. Well, what I do anyway. What you do is entirely up to you, isn't it? So I'll see you in part 2. Bye for now.